Hello, everyone. We'll talk about testing serverless applications today. I'll start with a story, and it's a story about Alex. And Alex is just the ordinary software developer. He's mostly working with JavaScript. He does some Node.js. He works in a small team in a company that does different applications and things like that. He's something like me or many other people. And of course, Alex has some friends. And his friends recently are talking about something called serverless and AWS Lambda a lot. From time to time, they're so boring, Alex can't listen to that anymore. But at some point, because he loves his friends, he's kind of interested into that serverless thing, and he wanted to learn more about that. The explanation was something like, whenever you want to build some kind of application, you need different things to support that application and to be able to run it. First, you need some kind of server, and now that's a cloud server or something like that. But that's not enough. Then you need some kind of operating system and things like that. Then on top of that, you need some platform and frameworks and things like that. And finally, you can put your application on top of that. And when you publish your application live, people start using it, and then more people, and even more people, and your application is starting being popular. But at some point, that server that you're using has some limits, and under a huge load, it can basically crash. And then, of course, your business is not happy because your application is not working anymore. So there's, of course, a solution for that. You gather some smart people, they're talking and doing some metrics and things like that, and finally they realize that you need to scale that server. And then you'll be able to support more and more traffic. But the issue with that is that it's expensive. It's like costing more and more money because sometimes you have unexpected peaks and things like that. You don't know every time when people will come to use your application. So with serverless, it's a bit different. You basically write your application and then put it in something called AWS Lambda or Azure Functions or something like that. And it should kind of just work. Like when you have some users using it, your application will be served to those users, and you'll pay just for those requests. And of course, if you have more users using your application, it will magically scale in the background, and you'll pay only for those requests. So it kind of looks great, but of course, Alex had an important question, of course, and it's, why is it called serverless? There are servers in the background, of course. And the best answer is from my friend called Gojko Adžić, and he said that serverless is, Lambda is serverless the way Wi-Fi is wireless. So you have your phone, and you try to load Google or something like that. You don't care about wires. You don't have a wire connected to your phone. But whenever you try to load Google or maybe check your email, there's a router somewhere over there, and there's a wires behind that router. So it's wireless for you, but someone needs to maintain all those wires and still be sure that they're working. But if something breaks, it's not your problem. Someone else will fix that. It's the same way with serverless. So there are servers somewhere, but who cares? So Alex had a next project with his team, and he had a great idea. Let's try to use this serverless thing and to build this project with it. And he presented the idea to his team, and of course, in every team, there are some people that are that want to do that, and other people against that, and some people are just don't care about technology and things like that, so they decided in the end to try that. But they had a first issue, and that's how can they just fit serverless into their process of developing web application. And they have some common process. For example, this simplified version of that process. They start with feature development, and they think about that feature. And if that feature is not that complex, they start with the code. So they love to talk about TDD and things like that, but most of the time they don't use it. So they start with the code. They run that code locally, test everything. And when that works, they add some tests and iterate for a few times, and then finish the feature, push it somewhere, and then CI builds that. For more complex feature, they start with TDD, like write some tests for complex logic, then write some code, then test everything locally, and in the end, again, push that code to CI, and everything is deployed somewhere to some development environment or test environment or something like that. Then they have manual QA team that is, they have a QA team that is manually testing that application, and when everything is done, they push it again through CI and deploy that to production. So they kind of start with the same flow and try to fit serverless into that flow. So they started with the first feature. The first feature was something really simple, so they kind of started with writing the code and testing everything locally. But then they had the first roadblock, and the first roadblock was, wait, let's introduce one more person before we continue, and that's me. So I'm Slobodan Stajanovic, and I'm CTO of Cloud Horizon and startup called Vacation Tracker. I also wrote the book, Serverless Applications with Node.js, and during the lunch, we have kind of book signing. It's more like we'll give away some books. And I'm also AWS Serverless hero, and I'm always writing about serverless on my Twitter account and also on the website called Serverless Pub, so you can follow me online. And let's get back to the story, because that's something that is interesting. And how do you run serverless application locally? It's not trivial at all. So can you even run something that you built for serverless environment for AWS Lambda and things like that locally? Well, if you Google that, you'll realize that there are some tools. For example, if you're using Azure Functions, they have some core tools that allows you to run Azure Functions locally. With AWS SAM, you have the thing called AWS SAM CLI that will allow you to run functions locally and even simulate API gateway and a few other things. You can use some third-party services. There's something called Local Stack and probably many others now that you can use, again, to simulate some different cloud services and things like that. With AWS, you can go and use Docker Lambda, which is basically used in AWS SAM CLI to run, to simulate your functions locally again. And there are many other things. With Node.js, for example, you can just run your function in your terminal like any other Node.js function. But all those things are good for functions, but functions are not that complex. What about some really complex things, such as like AWS Cognito for user authorization, authentication, and things like that? How do you simulate that locally? Or even Kinesis or many other services. Even databases are not like that trivial anymore. It's not like you can install something like DynamoDB locally, but again, it's not working the same way as it works somewhere in the cloud. So there are parts of your application that you can run locally, make sure that they are working fine, but you can test everything locally exactly the same as you will do that on the final environment. The good thing with serverless is that environments are not that expensive because you pay per use. So basically, you can do something that was probably crazy stupid at some point when you planned your infrastructure and buy servers and things like that. But now you can build another environment for each developer and even test each tester. And all those environments don't cost you much. They cost you only when your team is using them to test something. So it's really cheap now to have many environments and simply test your application in production-like environment on the cloud. And of course, you can do better because when you deploy everything on cloud, some things can be really slow because still need the deployment. You need to wait for CloudWatch logs and things like that. And if you use AWS, you know that CloudWatch is not the fastest service there. But the better way to test everything is basically to write automated tests. And that leads us to the second roadblock that Alex and his team had, and that's how do you test automatically AWS? Sorry, not AWS, but any kind of serverless function. And let's talk about automated testing. So why do you need to test serverless application? Your infrastructure is managed, so someone else will make sure that everything scales, that everything works in the background. But the thing is that your code is still like your responsibility. Your business logic issues and bugs and things like that will still exist. They can just scale faster and reach more people now because it will not crash your full application and things like that. But you still need to make sure that your business logic is working. And what tools can you use for testing? I'm mostly working with JavaScript and same as Alex that I'm talking about. So they realized that they can use tools that they already use, such as Jasmine or Jest or Mocha or many other tools for basically for JavaScript. But it's the same with other programming languages. You can still use the tools that you used before serverless with traditional applications. So the other thing is, what should you test in serverless? Because some things change, so it's probably different now. You don't need to test the same way as you tested the traditional applications. So who knows about testing pyramid? Some of you. Cool. So testing pyramid is something like this. Without that thing on top, I added that. So it's the idea of testing pyramid is that unit tests that are testing your function in isolation, any kind of function, are the fastest and cheaper because you don't need to create a new database and to connect that to your function to test it with like integrations and everything. You basically just mock things, run your function, and see if you get the results out. And that's why they are fastest and also cheapest. And you should have a lot of them. With integration tests, you're testing your services with in integration with other like different services. So they're more expensive and slower because if you want to check if something is working with the database, you need another instance of the database that will receive some data and then store some data, and then you need to read that data, and they are faster, slower, and also more expensive because you need more things to assemble to be able to run them. So you need less integration tests. And in the end, you have end-to-end tests and some UI tests that are the slowest ones because you basically need a full copy of your application. And you need to simulate clicks maybe and things like that. So they're the slowest and, of course, most expensive. And finally, most of the applications still have some manual testing on top, which is definitely the slowest kind of testing and the most expensive because you need people to check all those things and see if they're working properly. So how would that testing pyramid work with like serverless? I would say it's still kind of pyramid, but not the same pyramid. It's more like Mayan pyramid or some Aztec pyramid or something like that. So you still have unit tests that are fast and cheap. That didn't change a lot. You need a lot of them just to be sure that your functions are working in a way you want. Then you have integration tests, but they're faster and cheaper and more important than ever because your serverless application is split into many small services and they're working together. So you need to check all those things, but they're faster because you can just scale them. And you don't need to wait for DynamoDB to be like set up or something like that. That's already done for you. You just can spin another table in DynamoDB and test against that. And they're cheaper because in serverless you pay per usage. You don't need like to rent another server to wait for like integration tests and things like that. You can create a database when you need it, test against it, and then delete that table, and it will not cost you anymore after that. Also, UI tests, they're faster and cheaper, and we'll see why later, but basically you can parallelize some things, and it's cheap for you to have the copy of your environment, the same way you have a copy for your environment for other developers and things like that. And in the end, you still have manual testing that is like the same as it was. It takes time, and it costs a lot because you need to pay people to do that. So, as I said, integration tests are cheaper, but more important than ever, because if your Lambda function or Azure function or Google function is working fine, that doesn't mean that your application is working fine. It needs to be integrated with many different things, and you need to check that. So, the things that we can test, and mostly do test, are functions. But how do we write the testable functions? And there are some risks that we need to be sure that we are handling properly. For example, first, there's configuration risks. And for example, if you're connecting your function with DynamoDB database or something like that, you need to check if you're connecting to a right database. Do you have right access rights to read or write to that database and things like that. Then you have technical workflow risks, such as like if you're parsing your event, right, if you're handling your errors and things like that. Then you have business logic risks. is your business logic doing the thing that it should do and things like that. And finally, you have integration risks, which is basically, do you have good integration with, between those services? For example, the good example with DynamoDB is in your tests, you can probably store something that is called status or something like that. But when you try to do that with the real DynamoDB, you'll see that that's the reserved word, and it can still fail. So in order for Alex and his team to be able to kind of think about all those risks and to test against them, they're using a thing called Hexagonal Architecture. And creator of Hexagonal Architecture, Alistair Coburn, explains that in a way that Hexagonal Architecture allows the application to equally be driven by users, programs, automated tests, or batch scripts, and to be developed and tested in isolation from its eventual runtime, which sounds like a perfect fit for serverless, because you should be able to test locally and then deploy somewhere, to test and develop in isolation from like full cloud environment, and then be able to deploy it there and be sure that everything will work. So it's also called ports and adapters. If you're traveling a lot, you know that you need a full bag of those things to be able to like charge your laptop or something like that in a different country. But you don't want to buy another cable every time. You basically just use a small adapter to just put it on your power cable and to be able to charge your phone or laptop. It's the same with your application. So for example, let's say that we want to write some function that receives some trigger from AWS Lambda, then send some notification to SNS or something like that, and finally store some data into AWS DynamoDB. So the idea is to write this function in isolation, and then to have few ports. First is event port that has different triggers. We have AWS Lambda trigger for production, but we also have local triggers, so we can test that locally. Then we have notification port, and we can connect AWS SNS adapter that will just send a message to SNS or local function, so we can test that, or maybe Slack if we want to change that at some point. And with storage or database port, again, we want to be able to connect to DynamoDB adapter, maybe MongoDB adapter or something else, but we also want to be able to test that in memory because we want to test everything really fast. So let's see how do you write each part of the test. So let's start with unit tests. And unit tests are basically the same as they were before. You need to test small units. You should probably fully cover your function with unit tests, and you should mock those kind of adapters because you don't care if they're working properly in unit tests. But then in integration tests, again, it's more important than ever. And it's different because you can use hexagonal architecture to test them. And of course, you need to be smart and to test things that you own. You shouldn't test things that you don't own. For example, you can test against Stripe or something like that, but that's probably not ideal thing for you. But you can create your own like adapter and test against that and make sure that your application should work with Stripe in production. And yeah, you definitely can use different adapters to test everything. So here's how does that look in practice in Alex and his team in functions that they write. So for example, they have some Lambda function that has two files. First one is Lambda.js file or something like that, or index.js. And that file is here without tests. It's just wiring the dependencies. And finally, it invokes some main.js function that is basically the business logic of their application. This main.js has their own its own unit tests and also integration tests, but it will not save files to, for example, file repository. Instead, it will use memory to just check, memory adapter to just check that integration. And then they use something called file repository that has its own unit tests and integration tests, but now they want to see that their file repository is really working with AWS S3. Then they can use the same repository in like 10 different functions, and they don't need to test each function against like the same file repository. They just need to make sure that this file repository and this in-memory repository has the same have the same interface, so they can just switch them. And let's talk about unit tests. And the question is, serverless is mainly backend thing. Why would we talk about UI and testing front end and things like that? Well, The thing is that UI tests are slow and really expensive. But there's a good benefit from serverless that it's cheap and it can parallelize things really fast and efficiently. So we can do something like this in the end. When we run our UI tests, we can basically put Chrome inside serverless function, and instead of run one track with your UI tests, we can basically do a parallel tests in like 10 different functions with 10 different instances of Chrome in each of them, and test like one flow of your application in each of them. So that makes UI tests cheaper and definitely faster than it were before. And there are tools you can use for that. There's a Lambda layer for Puppeteer, or there are tools like Appraise.qa and similar tools that allow you to just test things and use parallelization in the background. Now there are even more tools for that, but we'll not talk about that today. So Alex and his team kind of managed to finish the first feature, ship it to GitHub or something else, GitLab, some other repository, and now they came to CI part. So let's talk about CI and CD. And I will not go into details what CI, what CD. It's not in the scope of this talk, but that thing works as it worked before in any other application. So basically, you can use your favorite continuous integration tools to kind of test and deploy your application and to build your application. So, for example, you can use Jenkins. I know some people love Jenkins. Travis, Semaphore, AWS code pipelines, or whatever you want, and it will work with all of them. So basically, what we do, we basically automate, whenever we have a new branch or something like that, we spin up the new environment and deploy that serverless application to a new environment, and someone can test that, and then after that, it can go through different phases and end up in production really fast. So, for example, you can have different environments for production, QA, dev, and whatever, but you can also have different environments just for one feature or something like that. If you're developing a new complex feature, you can spin up the new environment and test everything in that environment. So you kind of manage to deploy your application, and then that application went to your QA team. So Alex sent his application to his manual testers, and let's talk about that. How is serverless affecting that? It's like, again, software things, so it shouldn't affect a lot, like manual testing and things like that. But again, the thing with QA is that they often need to test some things, and it's complex to deploy them and things like that. So stages and deployments are cheap and often really fast to set up. So basically, you can set up another environment for each of your tester, for each of your features, and having those test environments was never cheaper and faster to set up. There's also one cool thing. It's a bit more complex now with different tools that we're using for deployment, but basically you can test a function and then promote the same function without redeploying it to production. And that means that your team can test some functions and exactly the same code without redeployment or something like that will be promoted to production. And that's really powerful thing because you can make sure that things are properly tested and there's no like some weird things in between. And also, there's one cool thing. All of your serverless flows are complex now. They have some, for example, API gateway, then AWS Lambda, then maybe some database, and then again Lambda that sends some notification reports or who knows what. Or you can upload the image to S3, and that can trigger Lambda, that can save another image, and that can, again, trigger another Lambda and save something to a database, and who knows what. But all of those things cost some amount of money. And now with different tools, we can basically calculate the amount of money that everything is costing. And whenever there's some change or things like that, we can identify the flow that is more expensive. Or for example, we managed to calculate the cost of our bug 2-3 weeks ago. It was $2.37 per week. So now we can like make decisions based on money, not just on like if we should refactor something and things like that. We can just show the reports to our business people, and they can decide if we want to fix that or not, or we can just pay those additional $2.50 per week, and who cares? It's much more expensive to fix that. So Alex and his team managed to deploy their application, their first feature, and of course they lived happily ever after, of course, until one day there was an email from angry customers and more angry customers, and everything is broken for some reason. And let's talk quickly about risks and challenges with serverless applications, because it's not everything perfect, of course. First, you have deployment risks. And we said that units are really smaller and easier to test now, but deployments, triggers, and permissions are not trivial. So there are many things that can go wrong with your applications. And when I started with serverless, everyone kind of started with their own script for deployment of serverless applications and things like that. That's why we built a tool called Claudia.js. But you should definitely use some of the popular deployment tools that are well tested and that are mature enough. Some of them are, for example, Serverless Framework, which is probably the most popular one. Claudia.js, maybe someone, did anyone heard about that? Oh, nice. Also, AWS now, which is like AWS official way to deploy serverless applications now. And there are many other cool tools, such as Architect and many others. You can use any of them, and you should use some of them, definitely, because otherwise you'll have many different risks that you'll need to test your function against, and to be sure that everything is set up correctly. But also, that's when you deploy your application, it's not done. Your application will just work, but there are many different things that can fail. For example, you can deploy your application that works with, let's say, Google Drive API or something like that. And after 1 year, your application will still work, but maybe Google will change something without letting you know, or even with letting you know, but you didn't update your function. So your function is working, but integration between your service and some other service stopped working. So how can you prevent those things? Well, basically you can't. You can't just make all the integrations to work the same way that they've worked. But what you can do is to do a continuous monitoring and error tracking in your application. And again, there's a lot of great monitoring and error tracking tools for serverless applications. You can, of course, use some built-in tools, for example, for AWS, that's CloudWatch, X-Ray, and a few other things. And you can use some of the cool other monitoring tools, such as Hexagon or IOPipe or Lumigo or Tundra and many, many others. There are more and more monitoring and error tracking tools for serverless every day, and all of them are amazing, and you should use some of them just to be sure that your application is always work correctly with all those integrations. So for example, we migrated our product some time ago from MongoDB to DynamoDB, but some services were still on MongoDB, and we kind of added new services that were connecting to that MongoDB. And because we have a Slack tool, I'll show you that later, there are a lot of events that are hitting our database. So our functions are scaling fast, but that MongoDB wasn't scaling that fast. And there was an issue because everything was failing, not because of our application, but because of integration of our application with that MongoDB. Of course, you have different ways to solve that, but we wouldn't be able to even find the problem if we didn't have monitoring and everything. And serverless applications are often front-end heavy applications, so they have some APIs and things like that, now GraphQL and things like that, but you still need to track front-end errors. And there are many tools that does that. And 1 week, we kind of played with serverless and built another open source front-end error tracking application with serverless, and it's called Désolé. It means sorry on French. It's open source, and you can see how we did that. It's written with Hexagonal Architecture, but it's still not well tested. Unfortunately, we didn't have enough time. We literally spent 2 days to build it. And in the end, the team that worked with Alex was happy. They managed to deploy their application, and Alex felt really great. And he now was part of that group of people that are talking about serverless all the time. So that was basically it. Let's go to a really quick summary because I'm running out of the time. So you can Test locally some parts of your application, but not everything. You should use automated tests, and they're really important, but you need to be smart and test important things. You can use hexagonal architecture to stay flexible and be able to even migrate some things and test things in isolation and things like that. You should use CI and CD to do test deployments and to automate everything. Your QA team can test the function that can be promoted to production function. So that's really a great way to do everything. And you should definitely use Mature and well-tested tools for deployments, and you can track and analyze your errors. And basically, serverless helps everyone to build our products faster and cheaper. So you should definitely use it. And here are the few things that I mentioned during this talk. It's my post about hexagonal architecture and how we use it with more code examples and things like that. Cloudera.js is the tool that we built for deployment of serverless applications, and there's that error tracking tool that we built. I'll tweet the slides, you don't need to write this down. And here's the tool that we are building with serverless. It's called Vacation Tracker. So we had an issue with tracking who is on vacation and how many days people have left. So we built a small Slack tool for that, and now it's a full-featured web application, but it's fully built on serverless. And whenever you do something, it triggers some functions and do cool things in the background. So one more thing, I just want to mention my book with the old cover. We have a new cover. Sorry if I didn't put the right, oh, oops. I break it. So, yeah. Again? Yes. So during the lunch break, we'll have a book signing. Again, I have no idea what should I do, but we have 20 books that we can give away. So feel free to approach me, and you'll get some books. I don't know what's the plan exactly, but we have 20 books to give away. And that's it. Thank you very much.